Greetings, scholars. Let me see. Give me just a moment. Sorry about that. God bless me. All right. So no major announcements. I'm still working on midterm grades. I kind of got held up by one group. Their grade book was acting really funny, but we got to the bottom of it. So midterm grades should be updated within the next couple of days. Once you do see your midterm grade, all it is going to be based on assignments from the beginning through exam 2. So exams 1 and 2 with the corresponding homework. But keep in mind that the midterm has no bearing on your final grade. It's just a snapshot of where we are at this moment in time. 80% of your grade is going to come from your exam average, and then 10% from the homework and 10% from the quizzes. So I say that to say, if you do find yourself, like if you get your midterm grade and it's lower than what you would like, you are welcome to go back and like improve your scores for assignments. If you are going back and submitting old assignments to improve your score, I would encourage you to prioritize your exams first, as that's where you're going to get the most bang for your buck. And then once your exam scores are wherever you would like them to be, then you can work on your quizzes next. You want to save the homework for last, because that's where you're going to have a lot of work for minimal points, right? As usual, if you have questions about anything, feel free to either unmute yourself or type in the chat and we can talk about it. And we're going to kind of continue the topic from Monday. Monday's topic was section 2.1 on quadratic functions. So we're going to go ahead and do as many of the corresponding homework questions for that section as together as we can. Hey, Google, give me a random number between 1 and 19.
2.
Okay, let's start with 2. And for anybody that's coming late, I'll check attendance again at the 15-minute mark. Let me go ahead and mark these guys as absent so I don't forget. Let's see. Here we're asked to identify the graph of the following quadratic function. So here we have a quadratic function that's written in standard form. So in this form, we can quickly identify the vertex of the parabola as our h comma k. Standard form is a times x minus h squared plus k. So since we have x plus 1, we should rewrite that as x minus a negative 1. So then we can see that the h or the x coordinate of our vertex is going to be negative 1 and our k is 0. So or you can use transformations. This is a U-shaped curve that we shifted left by 1 and then stretched vertically by a factor of 2 and then turned it upside down. So the only graph that went left 1 has been stretched vertically by a factor of 2 and is upside down is A. All the others are missing one or more of those steps. Hey, Google, give me a random number between 1 and 19.
15.
A quadratic function is given below. Determine whether the given quadratic has a max or min value, then find this value and find the range. So for quadratic functions, they're U-shaped curves and the max and min is going to occur at the vertex, right? So with this U-shaped curve, because the leading coefficient is negative, that means our curve is going to open downward. If the curve opens downward, that means we're going to have a maximum value. So we're going to go with the maximum. It's going to have a maximum value. Okay. And then what is the maximum value? Max. Okay. So that's going to occur at the vertex. So we can use the vertex formula to jump straight to the vertex. This time. There you go. So the vertex formula, give me just a moment. Come on. Is as follows. It's going to be h equals negative b over 2a. And again, this is going to give us the x coordinate of the vertex. So our b in this case is 8. So that's going to be a negative 8 divided by 2. And our a is negative 2. Okay. So notice we have a double negative going on. So that's going to be a positive. 2 times 2 is 4. 8 divided by 4 is 2. So the x coordinate of our vertex is 2. Then we just, to get the k, which is the y coordinate of the vertex, we just plug it back in. So then 2 squared is 4 times -2 is -8. Plus 16 is going to be a +8. Minus 5 is going to be 3. So the corresponding y is going to be 3. I'm just going to get rid of these notes. So the maximum value should be 3. Okay. So what's the range? So we have a parabola that's opening downward with a max value of 3. The range is the very bottom to the very top. Okay, so then the very bottom is going to be -infinity. And the very top is 3. And because our graph touches y equals 3, that gets a square bracket. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 17.
Okay, let's look at 17. So what's the time? Let me wait for like a few more minutes. I'll check Zoom again at the 15-minute mark. Solve the quadratic by sketching a graph of the corresponding quadratic function. Okay. Let's start with the vertex. -b/2a. 6 divided by 2 is 3. So when x is 3, I'm going to click on my parabola tool. I'm just going to click on like some random points. I just clicked on 2 random points. Now, our claim is that the vertex occurs when x is 3. When x is 3, let me see, that's going to be a 9. Minus 18 is -9, plus 8 is -1. So when x is 3, y is -1. Okay. And then this other point, we can do when x is 2. Or even easier, let's do when x is 0. When x is 0, the corresponding y is 8. So I'm going to drag this to 0, 8. Okay. So we plotted the vertex and then a second point, and we got an image like this. I'm going to hit check. So then the original inequality says, we're trying to find when is this quadratic positive? In other words, when is it above the x-axis? So we see our x-intercepts of 2 and 4. Let me make sure. 4 minus 12 is -8, so that's 0. And then 16 minus 24 is -8, plus 8 is 0. Okay. So yeah, when is this quadratic positive? In other words, when is this quadratic above the x-axis? Left of, what is that? 2 and right of 4, all right? So if we're talking about everything to the left of 2 and everything to the right of 4, we're going to capture that as follows. Left of 2 is going to be from where? -infinity up to 2. We're going to use parentheses because we cannot be equal to 0. We need this union symbol. And then we're going to say from 4 to infinity. And again, we're using parentheses because we cannot be equal to 0 from the original. Instead of that being the quadratic is strictly larger than 0, if that were the quadratic is greater than or equal to 0, then we would use square brackets on the 2 and the 4. Like if it could be equal to 0, then those would be square brackets. Hey, Google, give me a random number between 1 and 19.
16.
Okay. A quadratic function is given below. Also, so for the most part, with all of my students today, I've been doing the homework like this, and for the most part, each class kind of worked on a different set of questions, right? I did as many as I could with each group. So if you want to see more of these kind of presentations, I would encourage you to go back and watch my recordings from today with my 9 a.m., my 2 p.m., and my 3 p.m. Each group had its own set of questions that, some of those questions were actually interesting. So, whether we get here or not, that's why I like the little random thing, so that way I can have a different mix. So anybody that uses all of those videos together would have a more complete presentation. A quadratic function f is given below. Determine whether the given quadratic function has a max or min value, find the value, and then find the range. So we got a U-shaped curve that opens upward. That means we should have a minimum value. Okay. Because the leading coefficient was positive, that means it opens upward. The minimum value is going to occur at the vertex. So we need to find a vertex. The x coordinate, which is our h, is going to be negative b over 2a. Okay. So negative 10 is going to be positive 10 over 2, which is 5. So the x coordinate of our vertex looks like it's 5. So then the y coordinate, we're going to say f of 5. That's going to be 25 minus 50 is a negative 25, plus 16 is like it's a negative 9. So when x is 5, it looks like the corresponding y is negative 9. So the range is the very bottom to the very top. We have a U-shaped curve that opens upward. So then the minimum value is negative 9. So then we're going to do a square bracket, negative 9 to infinity. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 8.
Well, we tried to escape. All right, determine the quadratic function of this form whose graph is given on the right. Okay, so in the graph, they gave us the vertex and an additional point on the graph. So I'm going to use my standard form of a quadratic, which is a times x minus h quantity squared plus k. And then I'm going to plug in what's given. Now, right now, we don't have any information on a. Our x is going to be 3 minus our h, looks like it's what, 2 quantity squared, plus our k is 0, I can put it, equals our y value, which is 1. Okay, 3 minus 2 is 1, squared is 1, times a is a, plus 0 is a. So long story short, it looks like a is equal to 1. So then if a is 1, we're going to have what? X minus our h, which is 2 squared, and our k is 0. So we don't need to put that on the back end. This looks like our quadratic in standard form. I'm just getting rid of my notes. That guy. Okay, let's just confirm that these points pass through this quadratic passes through those points. So when x is 2, 2 minus 2 is 0, squared is 0, so that one checks out. When x is 3, 3 minus 2 is 1, squared is 1, so that one checks out. So I'm going to go with this. Okay. Let me check on you guys in Zoom. Let's see. You guys are looking good. All right, welcome scholars if you're just joining us. You know the deal. This is being live streamed, so you can always go back and listen to the announcements earlier. Hey, Google, give me a random number between 1 and 19.
Here's a random number, 13.
Oh, the one time I don't say 13, she chooses 13. So for this equation, complete parts A through E, does this parabola open upward or downward, right? So in order to determine if it opens upward or downward, we need to look at the leading coefficient. Notice that this is not put in descending power order. So it is a good idea to rearrange these terms so that they are in descending power order. So the highest power being the square means that our leading coefficient is a -1. Because the leading coefficient is negative, that means our parabola opens downward. So it has to be D, right? Parabola opens downward because A is negative. Okay. Find the vertex. So the x-coordinate of the vertex is going to come from the vertex formula, which is -b over 2a. Okay, so this will give us the x-coordinate. Our b in this case looks like it's -6. So -6 becomes a +6. 2 times our a is -1. Okay. So then looks like that's ultimately -3. That's the x-coordinate of our vertex. So then we want to plug this x-coordinate into the original to find our corresponding y. Let me see. 6 times 3, that's going to be a negative. Nope. That's going to be what? -9. Plus 18 is 9. Plus a -7 is 2. So it looks like when x is -3, the corresponding y is 2. So once we have the vertex, the axis of symmetry is the x-coordinate of the vertex. Okay. So for the x-intercepts, if I have do we have it? I guess not. Okay. I was going to use the standard form, but we don't have it ready to go. If we factor out a negative, everything becomes positive. 2 numbers that multiply to give us 7 and add to give us 6. It looks like it's x plus 1 times x plus 6. Let's go like this. So we have a negative, looks like it's x plus 1 times x plus 6. Right? Basically, I factored out a negative. Sorry, 7, right? No, wait a minute. That's not working. Because they need to multiply to give us 7 and add to give us 6. Yeah, that's not, neither of those are working. So we can use either the quadratic formula or completing a square. I'm just being lazy. I think I'm gonna do the quadratic formula here. Okay. So quadratic formula, x equals the negative boy couldn't decide. Let me do this real quick. Go back. Okay. So one way that one of my students remembers it, this is what he shared with me. The negative boy couldn't decide to go to the radical house. Come on. Because he was square. So he missed out on 4 awesome chicks, and it was all over by 2 a.m. Right? So that's the quadratic formula. That little narrative. That's that technique that you just saw me exhibit was called. It's called a memory palace technique. When you're trying to remember stuff, you create you might take the first letter of each component and associate those letters with something that's zany. The more zany the picture, the easier it is to remember. So when he shared this, to me, it was like a mini movie, kind of like the movie Hangover. And that's now how I remember the quadratic formula. There used to be a song, but I never really resonated with the song. But the story I can remember, right? Facts tells, but story sells. So let's plug in the different parts here. It's a little bit non-PC, but again, it helps me to remember it. So I'm just using the quadratic formula here. Negative b, so that's going to be -6 makes it a +6, plus or minus the square root. Now let me see, b squared, so that's a -6 squared is a +36, minus 4. Our a is what, -1, times our c, which is -7. It looks like a triple negative going on. 28, so we're in the clear. All over 2a. So then it's all over -2. Okay. So then if I simplify this down, we're gonna have 6 plus or minus the square root. Let me see. 4 times 7 is 28. So that's gonna be 2 and 6 is 8. So square root of 8 divided by, now, if I'm going to distribute that negative into the top, if I distribute that negative into the top, all that happens is the 6 becomes negative. Okay. And I'm going to go ahead and there's a couple of more steps I need to do. So let's do like this. -6. Okay, first let me get rid of some of these notes because I'm running out of space here. Let me get rid of all of this stuff. -6 plus or minus. Now, the square root of 8. 8 is what? 4 times 2. So the square root of 4 is 2. So that's going to be 2 times the square root 2 divided by 2, right? And then if we distribute the 2 into the top, or distribute a half into the top, we'll get -3 plus or minus the square root of 2. So those should be our x-intercepts. So there I use the quadratic form. I could have also used completing the square. I would have gotten the same result. I'm gonna go with this. Okay. So then for the y-intercept, oftentimes that's a lot easier to find than the x-intercept. If we let x be 0, the only term left is -7. So -7. Okay. Let's see. Do I have my vertex? We got our x-intercepts. Vertex is -3, 2. So I'm going to use my parabola tool. I'm just clicking 3 random spots. We said -3, 2. So I drag that's there. Let's solve when x is -2. So when x is -2, that's going to be a -4 plus 12 is what? 8 minus 7 is 1. So when x is -2, the corresponding y looks like it's 1. Was it 1 or -1? So when we went to the right by 1, we were at 1. So when we go to the left by 1, we should also be at 1. Right? So we're using the axis of symmetry to generate points. Okay, I'm gonna hit save. If I got it wrong, I know something I can do different. Okay, I think originally I said -1, but for some reason I put 1. I'm just gonna augment this. I'm gonna check when x is -2 one more time. So that's gonna be what? A -4 plus 12 is 8. Yeah, it should be a +1. Let's check when x is -3. Oh, yeah. Okay, let's see when x is -3. So that's going to be a -9. That's a +18. So that's a +9. 9 minus 7 is a +2. So that was supposed to be when x is +2. Sorry. I think when x was -3, we were supposed to get +2. So let me drag this to +2. And yes, I wasn't even thinking, I didn't even check it. It should be 3, 2. Okay. And that makes sense, right? Because our leading coefficient is negative. It is supposed to open downward. So we definitely graphed the incorrect vertex, right? So let's try this. Question cancel. Save. Yeah, check. Okay. Now it's been good all day. I want to wait till I'm just about ready to let the dog out, and then it starts raining. That's how life goes. Hey Google, give me a random number between 1 and 19.
Here's a random number, 13.
Okay, so the next one, let's do 14. A quadratic function is given below. Determine whether the given quadratic has a maximum min value, and then find the value and find the range. So because the leading coefficient is positive, that means our graph opens upward. That means we have a minimum value. Okay. The minimum is going to occur at the vertex. So let's find the coordinates of the vertex. Let's find the coordinates of the vertex. Okay. The x coordinate of the vertex is going to be our h, and that's given by negative b over 2a. Our b in this case is negative 16, so negative 16 becomes a positive 16. 2 times a is 4, so then our x coordinate is 4. Okay, so then when x is 4, the corresponding y, 16 times 2 is 32, minus, what is that, 64? So it's a negative 32. So it's like ultimately the corresponding y is negative 5. So when x is 4, the corresponding y is negative 5. Okay. The range. This was what, a minimum value? So since our parabola opens upward, the range is going to be the very bottom to the very top. So the minimum was negative 5 and it touches that. So it's going to get a square bracket up to infinity. Let's try to hang out for like 10 more minutes. Hey, Google, give me a random number between 1 and 19.
19.
If a baseball is projected upward from ground level with an initial velocity of this, then its height is found as a function of time and is given by this. What's the maximum height reached by the ball? All right. So the maximum of this is a parabola. It opens downward. So the maximum is going to occur at the vertex. The x coordinate of the vertex is given by h equals, come on. It's given by h equals negative b over 2a. Okay. Our b in this case is 128, so we're going to have a negative 128 divided by 2 times a negative 16. So we got a double negative going on. It becomes positive. 128 divided by 32. Hey, Google, what's 128 divided by 32?
128 divided by 32 is 4.
So after, what is this, 4 seconds, that's the time when we're going to reach the height, the max height. And the max height, basically we plug this 4 into our function and that'll give us a max height. Hey, Google, what's negative 16 times 4 plus 128 times 4?
Minus 16 times 4 plus 128 times 4 is 256.
256 feet, right? So the max height, it reaches a maximum height of 256 feet after 4 seconds. Okay. Hey, Google, give me a random number between 1 and 19. Hey, Google, give me a random number between 1 and 19.
$17.
Okay, I think we did 17. Let's do 18. Okay, let me see. Let me zoom in a little bit. Let's see one more. So this one, I'm actually going to take some notes and write it out. Okay. So fencing, it says fencing with a length of 720 meters surrounds two identical playing fields with a common side. The fields can be side by side and separated by a fence as shown in the figure. Find the dimensions and the maximum area of each field. So I'm going to start by drawing a picture. I know we have a picture, but I'm just going to draw one to use for myself. Actually, I think I am going to use their picture because I can. Paste. Let me crop. Okay. Undo. All right. So I'm going to let X be the distance from here to here. I'm going to let Y be the distance from here to here. Okay. We know that we have 720 meters of fencing, so that's like our perimeter. So we're given that the perimeter, notice that the Y length occurs 3 times and that length X occurs a total of 4 times. So then 4X plus 3Y equals like 720 meters. Okay. We asked to find the dimensions and the maximum area of each field. So we want to maximize the area. So if we want the area of one of the fields, this is going to be X times Y. Okay. So what I'm going to do, I'm going to solve for Y in the first equation and then plug that Y into the second equation. If I solve for Y from the first equation, we'll have 3Y equals 720 minus 4X. Okay. Divide both sides by 3, Y equals, let me see. This is 212 is 4, 240 minus 4/3 X. Okay. So then what I want to do is take this Y and plug it into my area formula. So again, we want to maximize the area. That's going to be X times Y, which is 240 minus 4/3 X. Okay. If we distribute the X here, we're going to get negative 4/3 X squared plus 240 X. Okay. So notice at this point, we have a quadratic, a U-shaped curve. The leading coefficient is negative, so that means our curve opens downward. Because the curve opens downward, that means we have a maximum value, and the max for a parabola occurs at the vertex. So we want to just jump straight to the vertex. So we're going to use the vertex formula. The x-coordinate of the vertex is going to be h equals negative b over 2a. Okay. So that's going to be a negative 240 over 2 times a negative 4/3. So when we divide by a fraction, that's the same as multiplying by a reciprocal, and double negative is positive. So we're going to have 240 times 3 over 2 times 4. Okay. The 2 turns the 240 into 120. The 4 turns the 120 into 30. So then it looks like we finished with 90. Okay, so our claim is that the maximum area occurs when our x is 90. Okay, so we're going to let this be 90 meters. So when x is 90 meters, then our y, I'm plugging into the equation that you see at the bottom of the screen. 90 divided by 3 is 30, times 4 is what, 120? So then it's just 120 is left over. Okay, so it looks like our maximum area, let me see, 90 plus 108, so 1080. So we get a maximum area it's 1080 meters squared. And this is 90 meters by 120 meters. 90 meters by 120 meters. You should like confirm that this works in the first one. Hey, Google, what's 4 times 90 plus 3 times 120?
4 times 90 plus 3 times 120 is 720.
Okay. Hey, Google, what's 90 times 120? And I think it's another 0 on there. Yeah, I think it's 10,800. Hey, Google, what's 90 times 120?
90 times 120 is 10,800.
Okay, so let's submit these results. So we got 90 by 120. And this will be it for us. The larger dimension of each field is 120 meters. The smaller dimension is 90 meters. The maximum area is 10,800 meters squared, or square meters. Okay. All right, gentlemen, I think that's it for me. Are there any burning questions before we go our separate ways? Going once, going twice. Okay. All right, gentlemen. So if there aren't any burning questions, we're going to go ahead and end the session here. And from one beautiful mind to another, have a great weekend. Next week, we'll just be moving on to the next section, which is section 2.2. I'm not sure what it's on. All right, gentlemen, have a great weekend. I'll see you next week, same time, same place. Take care. Peace.